So this is a group project. I know a lot of people will be in and out this semester, I'm assuming, considering I've gotten many emails about people testing positive for COVID or just generally being out sick. So a lot of this will be, it's a group project, but I think you'd probably agree with me that learning how to work remotely with other people is an important skill these days. So you can do all of this remotely. So keep that in mind as we go forward. If something major happens, obviously I'll switch things up a little bit. But I did this same project last spring when we were splitting classes. So half of the class was here half the time and the other half was on Zoom, and it seemed to work out fine because people just met virtually to get their group work done. So getting into this, the idea behind this is to investigate a disease that's associated with one or more of the systems that we're going over in AMP1. So it might be the skin, it might be tissues, nervous system, muscles, bone. I think those are the main ones. So all of the disease options, I'll talk about the options for you to choose from, which disease you want. At the end of this, I have a list of them. I put all this stuff on Canvas yesterday. So if you haven't been on Canvas recently, go check all of this out. All the deadlines for all the different pieces are in there. So I think everything is set up for the project. So you guys can get started whenever you want to. Last spring, I organized the groups, but I think this spring I'm going to let you guys choose the groups and just see how that goes. I know some of you guys aren't here and can't necessarily choose your group. If you have an idea, if you have a friend that you want to work with in here, we can kind of work that out. So after I go over the basics of the project, I'll let you guys kind of get into groups of about 3. There might be 4 in a group or 2, I don't mind, but mostly groups of 3 is what I'm going for. Okay, so the idea is I don't have time to get into all of the diseases, and a lot of times the diseases are kind of the really interesting aspect of AMP for a lot of people, but we have so much material to go over that you guys are going to investigate diseases and do an 8 to 10 minute video presentation on one of those diseases as a group. So the different parts of this, first you're going to select the disease that you want, and I'll show you the list at the bottom. You can pull this up on Canvas if you want to right now, if you have a computer. The first part isn't worth any points. You just have to rank your choices. So I think I have 11 disease options for you. You just have to rank your top 5. And hopefully, I think there should be like 6 or 7 groups in here. Hopefully you'll get one of your top 3. That's my goal, unless everyone, ranks them almost exactly the same. So the first step is ranking. After you meet with your group and set up your group, kind of ranking the different options from highest to lowest for me. And I'll try to get you guys, like I said, one of your top 3. That's going to be due January 26th, which I think is Wednesday next week. So it's due on Wednesday. It's not worth any points, but if your group doesn't submit one, only one person needs to submit it. If your group doesn't submit one, then I'm just going to assign you a disease, whatever I want to learn more about and no one else has selected. So definitely upload that in your own interest, because you want to be working on something that you find at least marginally interesting. This italicized part here, like I said, this is optional. I'll get into this in a little bit more detail as we get closer to it, but you guys know, do you know of Symposium here? You've heard of Symposium. So it's like a day that we don't have any classes. It's April 6th, I think, this year. No classes, there's a bunch of presentations happening. If you want to submit your project, you need the title and like a basic description of what you'll be talking about. If your group wants to submit it to present as an oral presentation at Symposium, you can. If you do that and your project gets accepted and you also present it at Symposium on April 6th, you'll get 10 bonus points on your final exam. I say your final exam, it doesn't really matter where I add the 10 points because every point in this class is worth the same amount. But just to simplify things, you'll get 10 points on your final exam if you present at Symposium. If only 1 or 2 people in your group want to present, we can talk about some options there too. But like I said, I'll talk about that as it gets a little bit closer. And this deadline is not my deadline, it's for the symposium submission deadline for, the formal symposium organizers. February 11th is when that will need to be submitted. So you'll already have an idea of what you're doing, and I can help you kind of put together a description if you do want to do that. Totally optional. You don't have to do that as part of this project. The next part after selecting your disease will be due February 21st. So a month later, after you have selected your disease, you'll do an outline. I think an outline will help me make sure you're getting the main points across. And I have a list down here of what you want to include in your video. You want to include those in your outline as well. So the name, the epidemiology, the causes, the main points of the disease. So just a general outline, and then also note in there who is responsible for what. As we get closer to that, I'll remind you and show you some examples as well. All of this will be uploaded to Canvas. So like with almost everything I do in here, I just want it's so much easier if it's just all on Canvas, it's all in one place. So keep that in mind, but I did note, always upload your documents to Canvas. I have most of the deadlines set for like the end of the day, 11:59 p.m. So it's not due by class time. All right, so that's only worth 15 points, not worth a whole lot, but that's part of the grade. And then the main piece of it is your video. We don't have time for everyone to present in person in class. So that's why I'm having you guys record videos. You can use whatever you want to record. I don't really care, as long as you have a slideshow, you can share the screen and then you're talking and explaining. You don't even have to have your face up. As long as you're explaining what the slides are covering, that's fine. So you record it, you'll post it to YouTube, and then you'll put the link to your video in a discussion board on Canvas that I've set up. So everyone can then go watch your video. These are the pieces that you want to include in your video. So the signs and symptoms, if there's a cause, the effects, epidemiology is basically, I've kind of described it here as the statistics. Does one group in the population seem to get the disease more often? Is there a region in the world that seems to get the disease more often? Those kinds of questions. Any treatment or avoidance of the disease, and then just a works cited page. So those are the main aspects that you want to cover in your 8 to 10 minute video. So it should be about 8 to 10 minutes. With 3 people, that's not all that much material or talking. When we get closer to you guys actually developing your video, I'll go over some stumbling blocks that have kind of tripped people up in the past and give you some suggestions for kind of how to put that video together. Okay, and then because this is a group project and I do this for every group project, you will be evaluating. This is only worth 5 points, but you'll send in a peer evaluation form. This is mostly to ensure that people aren't not pulling their weight. Everyone's pulling their weight in the group. If you're having issues, please come to me before this is due if someone's not doing their part or what they are supposed to do. But this will help me understand kind of the dynamics within the group. Generally, everyone gets the same grade in the group as long as there's no major issues. If I hear that someone hasn't done enough work or hasn't done any work, which has happened in the past, then they get a much worse grade, and the rest of the group gets the grade that they should get, assuming they would have had the help of this other person. So I'll keep an eye on that kind of as we're going through the semester. That's due April 4th. And then the final part, the other big part. So most of your grade is coming from the disease video itself. The other part is you watching everyone else's videos and then answering a few questions. So the links will be on the discussion board. You'll be able to get to the videos. You'll watch each one and then just answer these few questions. It shouldn't even be more than, I would say, max half a page typed for each of the videos. So only 4 questions, just kind of showing me that you watched the video and thought about it. And that's worth 35 points. So altogether, this assignment is worth 100 points. That is 2 test grades, if you want to think of it that way. And that's due April 18th. So you should have plenty of time between March 30th and April 18th to actually watch all of those videos. It won't take you that long. These are the disease options. I teach a 9 a.m. section as well. So if you have friends in there, these are different diseases. So don't let that throw you off. I just don't want to have, I don't want to be hearing about the same diseases over and over. It's mostly for me. All of these are associated with something, like I said, some system we're going over in this class, nothing from AMP2. So some of these are joint oriented, like gout. Some of them are skin oriented. Marfan syndrome deals with tissues. So what I would suggest, I'm going to give you guys a little bit of time to form your groups now. If you don't know who you want to work with or don't know anyone in here, you can just kind of talk to people next to you, or we'll work it out. For you guys on Zoom, if you have an idea of who you want to work with, you can let me know, or the people who are your friends in here can let me know. And then I definitely would suggest looking into some of these diseases. Like I said, you want to, it'll take maybe 10, 12 minutes to Google all of these diseases and at least get an idea of what it is. Don't be scared by some of the longer names, polymyositis. I think you've probably heard a lot of these, muscular dystrophy. But yeah, focus on the top 5 that you think are most interesting. And I'll let you guys kind of discuss that now. And then you can fill out that Excel spreadsheet that I have on Canvas and re-upload it with your rankings. Any questions in general about this? Okay, so get in groups of about 3. And then if someone doesn't have a group, we can try to match people up. And if you guys on Zoom have any ideas of who you want to work with, let me know. Recording again. Madeline, okay. Your question about the 6 elements that make up 99% of the body. So that's, if you look at the slides, it's like one of the first 2 slides in that PowerPoint presentation. So CHO, gosh, what else? Sodium, sulfur, and phosphorus. Like, I can't remember all of them, but yeah, they're on like one of the first slides on that presentation. Okay. What's up? Oh, which one? Nice, yeah. Yeah, I wonder. I'm like, dude, I don't know what people will be interested in. ALS has gotten a lot of press in the past, I don't know, 10 years or so. Like, isn't that the ALS, like the challenge? Yeah, exactly. Okay, what am I doing? Share. All right, here we go. Okay, I'm going back to the chemistry chapter. If you guys have any issues or questions about that presentation or that first part of the assignment, just let me know. Email me or talk to me before or after class. And I think I said this, but on that spreadsheet that you upload, make sure all of your group members' names are on there so I know what the groups are. I'll set you guys up as groups on Canvas. So when one person submits something actually for a grade, it won't keep showing up as like missing on everyone else's Canvas. I think that would bother me. It's bothered people in the past, so I totally understand. So it'll come in as like a group submission that way. But only one person needs to upload that Excel spreadsheet, and then I'll see the groups and put them together on Canvas. Okay. Any questions from the last lecture? We're going to continue on with a little bit of water and getting slightly more complicated, but still on the theme of water here. Okay. 2 really important aspects of water. I mentioned those 4 general characteristics on the previous slide. the two really important aspects that deal with how water reacts with other things in our bodies is that water is polar. And that means you have kind of a negative side. Here's a water molecule. You have two H's and an O, H2O. You have a negative side of the molecule and a positive. So the oxygen, this big red ball here, is pulling what closer into it to make it more negative? What particles is it pulling closer to it? Sorry, that was a weird way of asking it. Oxygen is holding on to some subatomic particle more closely than hydrogen is. What? Electrons, yeah. So oxygen pulls those electrons closer to it. They're sharing electrons here between the hydrogen and the oxygen. But the oxygen is greedy. It wants to hang on to the electrons a little bit more closely. So it pulls them closer to it, making the oxygen side of the molecule slightly negative and leaving the hydrogen side of the molecule slightly positive. That's polar. It has a positive pole and a negative pole. Polar molecules only mix with polar molecules. Polar and nonpolar does not happen. Nonpolar molecules, like mostly lipids, that's mostly what we think about in our body, oils and fats, do not mix with water because they're nonpolar. Those are two really critical characteristics that I want to make sure you understand before moving forward into the next topic. So into mixtures, we're going to talk about a few different kinds of mixtures, basically how water mixes with other stuff in our body. A mixture in general, mixture is just kind of the overall category. And I'm going to talk about three types of mixtures, like three subcategories in just a second. A mixture is just something that's physically blended, but not chemically combined, which just means there's no reaction happening. It's not like there's a chemical reaction occurring. They're just physically combined. They're mixed up. Most of our body fluids, by and large, are some kind of mixture. And that mixture is some kind of solute dissolved in water. So water is sort of the base for all of our body fluids, which isn't surprising. Water is the base for all the body fluids, saliva, urine, blood. Water is going to be the solvent. And then you have some kind of solute in there. So it might be salt, it might be protein, it might be red blood cells, some other kind of object suspended in the water. And I think on Wednesday, I said water makes up 2/3 to 3/4 of our body mass. I was wrong. It makes up 50%, so half to 3/4, just depends on age, gender, body fat content. I guess if you're really dehydrated, probably really old, your body mass is 50% water. So the older you get, the less water in your body. Men typically have greater percentage of water that makes up their body mass than women. So this number will be higher in men than women typically. And then fat content can also affect in different ways, kind of, the water content of a person's body. So it does vary a lot, half to 3/4. So that's generally mixtures. We're talking about water as the base and then something dissolved in the water. The three subcategories of mixtures that I want to talk about are solutions, colloids, and suspensions. So I'm going to talk about them in that order: solutions, and then colloids, and then suspensions. They're just three different kinds of mixtures that you can find in the human body. They're basically defined. The main difference is that the solute particles, so the stuff that's dissolved in the water, is a different size. So a solution has the tiniest solute particles. Colloids are kind of in the middle. Suspensions, and I'll talk about these on the next two slides, obviously. Suspensions have big solute particles. Does everyone know the term solute and solvent? Okay, the solvent is what's doing the dissolving, so that would be like water. The solute is what's in the solvent. So a protein, a salt, etc. That's what makes up the solution. The solute can be, we usually think of it as some kind of solid, like salt dissolved in water, right? It can be solid, it can be liquid, it can be gas. So we have oxygen and carbon dioxide gas dissolved in our body fluids. So that would be an example of a gas solute. If the solute is under 1 nanometer in size, so this is going to be the cutoff, anything below 1 nanometer, you have a solution. Solute particles, when they're dissolved in the solvent, do not scatter light. What that means is just you can see straight through it. So if there's something behind, if you imagine a test tube with a solution in it, and say there's a piece of paper with lines on it behind, or I guess for you guys it'd be behind here. Behind that test tube, you can see right through it and see those lines. So it's transparent. It might be colored, but it's transparent. It's homogeneous, which just means the particles are evenly distributed throughout the whole solution. And it will not separate out if you let it stand. So if you mix it up, you set it there on the table for a day, you're going to come back the next day and it's still going to be mixed up. You won't see the solute particles falling out. There's no separation. And I'll show you some examples of these, some pictures in a few slides. All right, so that's a solution. Moving up to the next size of solute, basically. So solutions have tiny, tiny solutes under 1 nanometer. Onto colloids. Colloids have solute particles that are between 1 and 100 nanometers. So they're kind of the mid-range. These do scatter light. Because those solute particles are bigger, they are going to make it harder to see through the mixture. So oftentimes they'll appear cloudy. Milk is a great example of a colloid. But just like with solutions, they don't separate out if you leave them there, say overnight. So milk, if you leave it overnight, doesn't separate, hopefully, right? If you have good milk, it won't separate out. If it does separate, something's wrong. So colloids will stay mixed. They're not going to separate on standing. Both solutions and colloids follow that characteristic. Suspensions are not going to. So that's going to be the biggest difference when we get to suspensions. An example of colloids in the body would be, like I said here, a mixture of protein and water. So proteins are pretty big. They need to be transported around the body. They're transported in our body fluids, which are, mostly the base water. So protein and water mixture is a good example of a colloid, even though it's not something you can really super relate to. All right, those are our colloids. On to the last category, suspensions. Even bigger solute particles. These solute particles are bigger than 100 nanometers. So you have the categories of less than 1, 1 to 100, and then over 100. That's what defines these different types of mixtures. Suspensions go beyond just being cloudy. They can be cloudy, but they can also be opaque, like totally, you can't see through them at all because those solute particles are so big. They're totally scattering the light. And the best identifying characteristic is that suspensions separate if you let them stand for a while. Our blood is a great example. If you have your blood taken, not that you would have the test tube of it, but if you're ever taking blood, if you let it sit for a while, it'll separate out into, on the bottom, you'll have mostly red blood cells, which are really big. And then on the top, you'll have plasma. So it'll totally separate out. The plasma is what the red blood cells are basically floating in. It's mostly water. There's a bunch of other stuff in it, but you'll have the plasma on top and the red blood cells on the bottom. That is a suspension. All right, so if we look at some pictures here, on the left are actual test tubes of stuff, of liquids, mixtures. On the right are just drawings, kind of giving a little bit more detail on that. So which of these, A, B, C, or D, A, B, C, D, would be the solution? Yeah, this is the solution. And which would be the suspension? Let's go to the other extreme. Yeah, C and D. So these are actually the same. But yes, this is over time, and this is right after the blood's been drawn. So this would make B a what? A colloid, yeah. So B is a colloid. So you can see the solution, you can see all the way through. So these test tubes are sitting in front of a piece of paper with lines behind them. You can see the lines perfectly through a solution. You can't see them through a colloid or a suspension. The colloid is cloudy and milky looking. And then the suspension, I have the names down here, I'll unblack them out. The suspension, this is, like I said, is blood. So right after blood is drawn, it all looks red. The plasma and the red blood cells are all mixed up. Here, after a certain amount of time, you get the plasma on top and red blood cells on the bottom. Red blood cells are really big and they're separating out from the plasma. Okay, so those are the three kinds of mixtures you want to be familiar with in the body. And then switching gears kind of again here, acids, bases, and pH. Not going to go into a ton of detail about this, but I do want you to understand what pH is, what it's measuring, and some of the basics behind it, because different systems in our body need to operate at a very specific pH, like very specific pH within a tenth of a pH degree, if you want to think of it that way. So very narrow ranges of pH are what our body operates under. So an acid and a base, everyone has heard those terms before. An acid donates hydrogen ions. That's the H+. So releases H+ in water. When you think of an acid, think H+. It's a hydrogen ion. A base, it's going to accept those hydrogen ions, so take them out of solution, basically, make something less acidic. I think of a base as donating hydroxide ions. So anytime you see like a molecule that's something with an OH on the end, like NaOH, that's sodium hydroxide, that's a really strong base. If you see the OH, it's a base. If you see the H, you know it's probably an acid. So like HCl, hydrochloric acid, it donates these hydrogen ions once it dissolves in water, and it's very acidic. Okay, so releasing hydrogen ions is an acid, accepting them or donating hydroxide ions is a base. So how do we actually measure pH? Sorry guys, you can't see that. Maybe that's helpful. pH is sort of a complicated looking formula, but really all it's doing is measuring how many hydrogen ions there are, how many H+ there are in a solution. If there's more H+, does that make it more acidic or more basic? More acidic, right? So more H+ means more acidic. Is that higher or lower pH? Lower, yeah. So I'm going to show you the pH scale in a minute, but down here, actually, you can see. Anytime the pH is below that magic number of 7, which is our neutral, it's going to be acidic. So if we look at the equation here, I'm not going to ask you to calculate pH, but I do want you to understand how this is calculated and where the log aspect comes in and the negative. Okay, so First off, this H plus in brackets here just means the concentration of hydrogen ions. Concentration of H plus. So it's measuring the concentration of H plus on a log scale. And I know no one really uses log in every day, right? But the log comes into play with this second bullet point that I have listed here. So if you move from a pH of 5 to 4 on the pH scale, so say you have something with a pH of 5, and then you have something with a pH of 4, it's actually 10 times more acidic. That's where the log comes in. So the log basically linearizes the scale for pH and makes it easier for us to understand. I want you to know that if you move from 5 to 4, you move 1 point on the pH scale, it's actually a 10-fold change in acidity. And then the negative aspect, whoops, I just covered up the negative. There's a negative. Cool. The negative in front of the log means that, this is the weird part, if you have more hydrogen ions, if this number goes up, the pH goes down, right? It's opposite because of that negative. So that's an easy thing to forget if you're thinking about the equation for pH, because you're thinking, well, more hydrogen ions means a higher, it'll give you a higher number here, right? But it's actually opposite because of that negative. So anything with a pH on the low side, below 7 is acidic. Anything with a pH above that neutral 7 is basic. Questions about that? I know a lot of people have heard that before, but if you haven't taken chemistry or general biology, you may not be aware of that. Okay, and here's the pH scale just for a visual if it's helpful. 7s are neutral, pure water is totally neutral. Everything over here is acidic, everything over there is basic. So it goes from 0 to 14. Our stomach acids are very acidic, the juices in our stomach. So very, very low on the pH scale. That's what helps actually digest and break down a lot of the food that we eat. Okay. That's all I'm going to say about pH unless you guys have any other questions. I'll mention pH in different systems of the body when we're talking about them. So I want you to know if it's acidic or basic in general. All right, into chemical reactions. So we talked a little bit about bonding between atoms. That'll come up again in a second. But in general, in our body, chemical reactions are happening every second of every day. Our bodies are breaking down molecules and they're building up molecules. That's your metabolism. So your metabolism is essentially all the chemical reactions in the body. The three main classes of chemical reactions are decomposition, synthesis, and exchange. I want you to know what an exchange reaction is, but I'm not really going to talk about them in any detail. Decomposition and synthesis are the two big ones that you want to know. Decomposition is what it sounds like. You break a molecule into its component parts. Synthesis is the opposite. You're building a molecule from its individual pieces. An exchange reaction is just where you have two molecules, maybe made up of two components, like this example, and they switch their relative components. So you go from AB and then CD. Now A is bonded with D and C is bonded with B after that reaction. So they just switch partners. If you're visual, this might be helpful for the three kinds of reactions. A decomposition reaction, a good example, and I'll talk about this when we get into the biological macromolecules on Monday, is a starch molecule, which is really big, being broken down into its individual pieces, which are glucose molecules. Synthesis would be like building a protein from individual amino acids. And if you don't remember all of this, like glucose and amino acids and starch, don't worry, I'll kind of remind you of that. Like I said, on Monday, when we get into the macromolecules, those will come up again. And exchange, like I said, I don't really have a great example. There's a lot of exchange reactions that happen, but I'm not really going to talk about them in any more detail. But again, they're just switching partners. So you have two molecules, they come together, they switch partners, and that is an exchange reaction. Okay, a little more on the basics of atoms here. We focused a lot on electrons, which is important, and we'll continue to focus on electrons. But I do want to make a note here that ultimately, whether an atom is reactive or not depends on the protons, which seems backwards because I've said, well, it all comes down to how many valence electrons there are, right? But the important part here is that the protons are attracting the electrons. So without the protons, you don't have any electrons on the atom. So if we think about our little atom here, you guys can see this. We have our protons, and then what else is in the nucleus? That'll come up in a second. Protons and neutrons, yeah. So I'm going to put those as zeros because they don't have a charge. And then we have our orbitals where we have a bunch of electrons, which are negatively charged. We'll do something like that. Okay. So these positive charges in the nucleus, because opposites attract, the positives are attracting these negative charges, the electrons, right? So protons are actually attracting electrons and holding them to the atom. So that's why I have ultimately underlined. That's just something you need to know. I won't go into too much more detail on it, but wink, wink, it's something you need to know. Protons ultimately determine the reactivity of an element. Okay. One more thing with neutrons. Neutrons I didn't talk about that much. I said I'd mention them one more time. This is basically the one more time that I'm going to mention neutrons. So neutrons don't have a charge. They don't seem all that important. But elements can have different numbers of neutrons. So a carbon atom can have a different number of neutrons. That's going to slightly change the reactivity, just a little bit. And those different forms of that element with the different numbers of neutrons are called isotopes. Isotopes, that's a word you're probably going to hear again in this class and then probably other biology or chemistry classes. So I definitely want you to know that isotopes are just an element with a different number of neutrons than the norm. So do you guys remember same number of electrons and protons, neutrons, that's the only difference. So we're talking about carbon. Do you guys remember what the atomic number for carbon is? 6. Nice. So here's our, well, yeah, I won't even draw it. So carbon has 6 protons, like the normal carbon we're talking about here. How many electrons does that mean it has? 6 protons, electrons. How many electrons if it has 6 protons? 6. Yeah, 6. 6 electrons because it's not charged, right? They have to even out. 6 electrons, and the normal form will also have 6 neutrons. There are different forms that have, like I said here, up to 8 neutrons. So once you add on neutrons, it's going to change the reactivity. And carbon with 8 neutrons is actually radioactive. So that changes it in a big way. The carbon in our bodies is not radioactive, which is good, right? That's because it's carbon 12. The number on the bottom here is the number of protons, so 6 all the way across for the different isotopes. The number on top is essentially the number of neutrons plus protons. So you have 6 adding to 12. This isotope would have 7 to get to 13. And then this is our radioactive one, carbon 14. And it has 8 neutrons. That's really all you need to know about isotopes right now, just a different number of neutrons, and it can change the reactivity. Questions? Okay. That's it for today. I'll see y'all on Monday. Thanks, you too. See ya.